I'm not going to say a whole lot more words. I'm going to introduce Dan Wagner, who's going to say not a lot of words. And we're going to start with some awesome content for the rest of the afternoon. Bathrooms are that way. And I hope everyone had an awesome time. And I hope you continue to have an awesome time.
Thank you, Dan.
Thank you.
That is a good point. Bathrooms right out this door right here, if anybody needs that. There's another door if you do want to drink a quick coffee break or something. We do have a kitchen down the hallway there as well. Someone can direct you. As you said, I'm not going to say many words here. I'll start out by thanking a couple of the same people. Karen, Sally helped me so much getting these details together, the food trucks. I would not have been able to do that without their help. So that was huge. I just want to give a big shout out here to Brad and Adam. The work that these guys are putting in, all the miles on the motorcycles, let alone, but individual presentations, all of the energy they're injecting into our community by doing this, like no one else is doing this. These guys are putting in huge amounts of effort. So guys, thank you so much for what you're doing.
I don't know if everyone's aware, as Dan mentioned, they're not giving the same presentation at every stop on this trip. They're giving new and different presentations every day for 6 days.
Every single day. Yeah.
5 days. Yeah.
So thank you all for making the trip out here on a Friday afternoon as well. That was another question, was like, well, we're going to occupy a Friday afternoon. I hope people join us. And I think it panned out. And Dan, I think you're right. Maybe this should be an annual
I think I'm right too. Yeah.
That just really went well. So thanks everybody for being here. I'm going to welcome Suchit up to say a couple words. And again, have a good time. And I can't wait to see what these guys put together for you today.
Before I'm going to interrupt for 1 second. I do want to say thank you to the 3D Connection guys. Thank you to Janice from Approved Sheet Metal somewhere around here. To all the sponsors that have donated prizes for us tonight that will be raffled off in the back of the room at the end of the night. So thank you guys.
Well, Manish is here as well. Manish, why don't you come up as well here? I saw you riding on the motorcycle. So,
Without a helmet.
Well, the good news is Manish has been, Manish just picked up your dad, right, Manish? That's why, yeah. So he was in what, New Jersey somewhere, JFK, and he drove all the way back here to be with you guys. So that's great. But I wanted to just again thank these two guys, Brad and Adam. It's amazing. By the way, he said to call you Bradham, right? Bradham. And I'm like, if I go Adam and Brad, or should I go Brad and Adam? But I was lucky enough. They invited me to Altec, amazing company. They had their designer forum, which the guys had arranged. And this was the only room I've been in front of a lot of users, except 3D Experience World or SolidWorks World. That was the room largest. If I ask a question, how many SolidWorks users are there? I think it was 80% of that room, hands went up, and it was 300 or so.
It was 180 users.
180. So yeah, I mean, more than 150 SolidWorks users in one room. So Altec they have user groups within their bigger company as well, which thanks to these guys, they've been doing. So thank you guys for all the motorcycle riding and all the work you've been doing so far. Manish, you want to add something from your side?
Yeah, it's always fun to see your excitement. I'm not sure if you followed the story at 3D Experience World. Brad, on day one, he committed that he would have shaved his beard if we were able to raise what, $5,000? $5,000 for Magic Wheelchair. Then we raised what, 25,000?
Well, we announced on the stage what $30,000 check. So there we go. It just went boom.
So it's funny how fast his beard grew. Not his hair, by the way. So, but it's really exciting to see your commitment, your energy, your passion.
So maybe next year we do a bigger event of IronSWUG here with something related to your hair,
But if you have not followed that story, you should go on LinkedIn and try to see that. There was a full story on that. On daily basis. I was even made to eat some really spicy chips in order to raise that money. For a few minutes, I was braving myself in the sense, okay, you know what, I'm an Indian guy. What does spice mean to me? And there were two other guys from UK, and they were sweating and tearing up. And I was able to hold my tears for 2 minutes, I would say, but ultimately it did roll out. But that was fun. So with you guys, it's always fun.
Yeah. So one more thing which we wanted to just share with you. I know some of you already know, a lot of you already know. On July 1st, we have this big announcement which we did make the announcement at 3D Experience World about really empowering our users beyond SolidWorks and really make SolidWorks connected with the power of cloud and the ability to, we called it e-drawings on steroids at the time, but this idea that you can share and mark up and do all kinds of things from within your SolidWorks. So Manish and the team in R&D has been talking about it, and they've made it happen. And that's going to be happening there. And there's a lot of business changes because of that, because we want to make sure all our users have access to this. So if any of you will take a few minutes here, Manish is here as well. I mean, his team has done an amazing job on making that happen. We got earlier this morning, we ran an internal event, and Sally and the team did a demonstration of share and markup within SolidWorks, and it was amazing. So I think this is coming very soon. But if you guys have any questions, we are here. We'll maybe, you know,
A large part of the team is here. They're sitting in the back.
yeah, the
not
team is
taking
here
any
as well.
gaps.
So if anybody has any questions, no question is a taboo. So feel free to ask.
Yeah.
We'll take a few minutes and then we'll hand it back to these guys. Anybody? No questions? You guys all know what I'm talking about? Anybody who doesn't know, let me put it that way. Okay, raise your hands if you know what I'm talking about. Okay, everybody knows. So I think we're good.
Looks
Okay.
like it. Okay, thank you.
Thank you, guys.
Thank you for coming.
Thanks, John. I'll take both.
Mm.
All right, so
No, it's fine.
without any further ado, I'd like to welcome Bradham to the stage.
Oh. Okay. Yes, tank. Tank 'em. All right.
Screen is sharing. So thank you guys for coming out today. IronSWUG 2023. This is our second rodeo. We started our first one last year. It was actually a brainchild back in 2020 and 3D Experience World in Nashville. And COVID kind of put us on hold, so we didn't get started until last year, which worked out great. We really got to inject some enthusiasm into the SWUG groups and get them running and back up and going again and give them some excitement. Let's start off real quick. And I know some of this has already been mentioned. I want to start off real quick by thanking those sponsors. I know we have approved sheet metal that's donated some gift cards and stuff. I also want to talk about some of these other sponsors, but Altec Industries, that's the company Brad and I work for. If anybody's looking for a job, we're always hiring different people for different things. If it wasn't for them, it wouldn't be possible for us to be here today, right? We wouldn't be able to get away from work and our normal duties at work to come out and talk to everybody and do these presentations. The second greatest sponsor we have is the SolidWorks User Group Network with Dan Wagner supporting us and doing this. We really thank Dan and the User Group Network for allowing us to do this, because of course, without that, none of this would be happening. Without the User Group Network, it just wouldn't exist. So we want to thank them. Hewlett Packard, they've done a great service to us and helping sponsor a lot of the funding for the food you guys ate today, as well as loaning us some laptops to test out and see how they work with the software and allowing us to give them feedback to help give other people feedback. And if it's a good process or a good computer to use. 3D Connections here today. They've got some awesome door prizes here and done so with some of the other stops we've had. Go Engineer and Trimec have been great. Go Engineers gave gift cards at every location, including this one. We've got 4 gift cards for door prizes here today from them, 2 from ASM. So we really do appreciate the VARs and their enthusiasm and getting behind the SWUG groups and helping them out. Of course, DriveWorks. DriveWorks has always been a great sponsor for the SWUG groups and always been there and participating and giving swag and stuff. So we definitely want to talk about them and let them know we are appreciative of that.
Hi, Heather.
Hi, Heather, if you're out there.
I see her in the chat. Hi.
There she is. We are going to play. So between our presentation and Jason's presentation, when we swap presentations, we're going to play a video from them to just let you know how their product is and what they have to say for it.
Yep.
To you. All right, so let me go ahead and minimize that. Getting started, I want to introduce myself. I know we kind of had a little bit of an introduction at the beginning, but my name is Adam Ebernickel. I'm a senior designer in the product engineering department of Altec Industries. So Altec basically does digger derricks, aerial devices, bucket trucks, tree care, wood chippers, you name it. That's kind of our game. We just facilitate building and designing those trucks.
Right, down here at the end of the street next to the courtyard, there's actually a couple of our units right now replacing power lines up on poles. So it's always great to see that stuff out there.
Sure is. Been doing that for 10 years, but I've also been doing adjunct teaching in the applied engineering department at Mayland Community College. I do about 3 classes a semester. Been doing that just about as long as I've been doing working with Altec. I just really enjoy getting in front of people, talking to people, encouraging the youth and STEM products or STEM individuals to get better and do new things. I do lead the Western North Carolina Asheville SolidWorks user group. I've been doing that for probably 7, 8 years. That in turn has kind of led me into becoming part of the committee of the SWUG group of the whole Southeast region. So basically Tennessee, Mississippi, all the way into the Virgin Islands. As Suchit said, we do have SolidWorks user groups now within Altec. So we got 6 off the ground last year and 6 different locations, 2 more this year, looking at 2 more towards the end of the year. And so I'm also the committee member and helping with that. That basically just means I have little stewardship, and if they have questions or need something, they just holler at me. And instead of bugging Dan all the time, I kind of help mitigate or mediate that a little bit. SolidWorks Champion, that's another great program that Brad and I are both part of. Matt Clegg, if you want to get to know that, Matt Clegg can help you out. If you don't know about it, go on Google and search SolidWorks Champion. It's a great way to give back outside of the SolidWorks User Group Network, right? There's a lot of cool tools that have became available thanks to Matt Clegg and a lot of other individuals, Dan Wagner, Suchit, and all those guys that we've been able to experience and look at. So we really appreciate that program, as well as giving back to people like Magic Wheelchair and projects that we can invest in and try and help out the community. Through all that stuff, I've also became a SolidWorks certified expert. I really enjoyed going through the certification program and fine tuning and honing my skills outside of my normal design, right? I tell a lot of people, do the certifications. I know it may not be applicable to your job, but it will make you a well-rounded SolidWorks user. And once you are, you can find other tools outside the box to solve solutions for problems you may have. Myself, looking forward, I'll probably try and go to the platform certifications next.
Okay. So I'm Tank. My government name's Brad. I'm a husband, a dad. That's the greatest job ever. I'm a motorcycle minister. I'm electrical engineering student and just an overall tech nerd. Project designer as well at Altec, 10 years there, and I'm grateful that they let me do this as a job, because who couldn't be more happy with riding motorcycles and presenting and get paid for it. So it's really fun. I am the Star City SWUG user group leader, as well as the committee member for the Mid-Atlantic region for SWUGing. I too am a SolidWorks champion and a certified SolidWorks expert.
So our presentation today, it's motorcycle modeling mayhem, fine-tuning your SolidWorks designs. Now we've decided to do something a little bit different today. I'm gonna go through some key takeaways here in just a minute. But standardly, Brad, how are most presentations given?
PowerPoint.
PowerPoint, people go through. Not saying it's wrong, right? PowerPoints are great. You learn a lot from them. But you go through a PowerPoint slide, you talk about SolidWorks, you go into SolidWorks. We wanted to change things up today, not only in that aspect, but Brad and I, as was mentioned, we give brand new presentations every time we get up, and it's usually separately. I'll give one, he'll give one. The next day he gives one, then I give one. And we kind of alternate back and forth, but we both give one at each location. This is the first time that Brad and I have combined our presentation into one presentation. Just work together and have some fun, right? That's the key to it. So, and talk about those key takeaways.
So, first one, try new things.
Explore the platform. A lot of cool tools there.
And finally, be creative. Go out outside your comfort zone, try something new, and just explore and experiment with your design capabilities.
So we wanted to start by telling a story. I'll go back and I'll leave that up there for just a second. We want to go tell a story, right? This is a story about a couple of guys who decided to go outside their comfort zone of their normal job and create a motorcycle upfitting group. Now, during that process of that motorcycle upfitting group they're trying to create, they learn new tools, new processes, things that may be on the platform, as well as tools that they may have learned at a SolidWorks user group. So we're going to talk about those things as being those two guys in this hypothetical situation, right? And some of the stuff that we started with and have found through that journey. Now, in that journey, the first thing we found was this chat messaging board.
Yeah, so as some people know, having a small business and playing around with trying to figure out money and software and everything, we stumbled upon, but we've gotten the access to the platform. And so we're spitballing designs back and forth, getting ideas, up and down through the chat, and yeah, using the communication process of it.
It was great. So I go in there and I'm like, hey, Brad, guess what? We finally got those renders from Paul's upcoming bike. Paul is a guy who's invested in getting a bike and having it brought in and then having it upfitted and having some pretty cool stuff tweaked to it. So I throw it in there and Brad's excited. He's like, let this design begin. And so we created a whiteboard. And in this whiteboard, we went ahead and threw those renders in that we got from the vendor. The vendor's creating the bike and they sent us the bike renders and a little photo package of what we were using. So we threw that in there, right? But I guess the cool thing about it is when we're talking back and forth, Brad tells me some of that stuff's in there, that we've got it uploaded, and I'm away from my computer. And Brad goes in there and denotes, he got a message from Paul that said, I need a speaker box on the front of this bike, some type of fairing, something that I need to just be able to listen to music because I'm going down the road and maybe cut some wind as well, right? I'm not near my computer. I do have my tablet with me. Actually, as a matter of fact, I have a folding phone device. Anybody seen these? They're really cool. You go in, you unfold it, comes with a pen. I can even draw with it, right? And so it's a really cool device. And because of having that, I'm gonna play a real quick video for you just to save us some time here of what happened in this process. So Brad sends me that message, and anytime anything's updated on that whiteboard, I get an email after he publishes it, letting me know something's been updated so I can check that out from my device as well. And so I see that message, and this is what I do for my tablet. Now, remind you, this is a tablet. It's a screen capture from my tablet. You can even see the date and time, and it's all happening. My battery power at the top's 90%, right? And so this is what happens. I go in there, I look at the message. I'm like, oh, Brad's got this note in here, right? Okay. So he put a note in here, need to create, hold on, it's loading. Need to create speaker box design. So I'm using my two fingers. You can kind of see the points there where I'm moving my two fingers. Grab the note, move it off to the side. Now, I'm gonna go ahead and pause the video here in just a second, just so I can talk about this pencil tool. This pencil tool has three options at the bottom, the assistant, the snapping, the smoothing, and the shape recognition. Now, why is that important? I turn on all three for my example, because the snapping, maybe I'm not good at drawing everything perfectly and I want to do it in line segments, right? But it helps snap those lines together, and I'll illustrate that and talk about it when it happens so you can see it. But it also has smoothing. The smoothing, if I'm doing these jagged lines and I'm not exactly correct, it's going to smooth those lines out nice and easy for me. And then shape recognition. Who in here can draw a perfect circle? That's what I figured. Oh, we got one. Yeah, Jason Pohl, of course. I figured you would. So not many people can do that. It is an art to be able to draw a perfect circle. Within the whiteboard, when you sketch with a shape recognition, it understands that shape and snaps it right in. Whether it's an ellipse, a circle, a square, a rectangle, a triangle, it's going to understand it and it's going to create it for you. So I'm going to go ahead and I'm going to turn all three of these on.
Eric raised his hand in the chat too.
Oh, awesome, Eric. Cool. So at first I go ahead and draw this arc and it smooths it out. Then I draw this line. See how rough that is, but see how it connected. Now the next one you'll really see connect. So it comes down. I passed that line completely and it reconnected that for me. And so it really helps me grab those points. Now the next thing I'm going to do is I'm going to trap the selection. Watch, I go and select this trap selection. What's the difference between trap and trace? Well, trap is almost like you select it with a box and get everything inside that box and it selects it. Trace, you'll go over it, and I do an instance of that here in a second. So I'm gonna do trap selection. I grab all of them, see how it located every one of those lines. They were all different, right? You see the little boxes, and now when I grouped them, you're basically grouping them just like you would in PowerPoint or a lot of different softwares. It's grouping them. So now that it's grouped, I can kind of minimize it, shrink it, put it away a little bit where I want, and then I do a Control-C, Control-V, because we all know the front and back of this is going to look about the same, at least the outline profile, right? So Control-C, Control-V for my back view, because that's the front view. Kind of readjust them, move them around a little bit. Now, two fingers, I'm zooming in there on my tablet, my phone. I grab the pencil again. This is a horrible ellipse, but it understood it. It made my ellipse for me, right? Then I readjust it, resize it, kind of put it where I want. And then I draw some lines. The lines get straightened out for me too, except for the two on the left. I have to redo them. There's some points where you just draw so bad it just won't recognize it, but that's understandable. So it straightens those out. Now I want to do the trace selection on this part. See how I traced all that? I selected all, grouped it. I copied and pasted it. I'm going to bring it over to the other side, do a little rotate, almost like a mirror in a way. Rotate it out, make it smaller, and put it in place. That's going to be the inside of my fairing. Now I trap select it all and group them all together, right?
And it's auto saving where you're doing it too.
And it's auto saving while I'm doing it. Now in saying that, that's the inside of the fairing. That's where the speakers are going to be housed inside of that fairing, right? So then I grab Brad's note, bring it back down to tag it on top of what I'm doing. I go ahead and publish it. Now Brad's got the email saying, hey, I went ahead and drew some sketches in there for what we may wind up designing.
So, go ahead.
I need to quit sharing. You got to share now.
Yes, I know. All right. So part of this, part of working with vendors and whatnots is we get vendor parts, right? Everybody get supplier parts. Raise your hands if you do get supplier parts, and you have to figure out how it was made. Open it up, it's blown up, you know, or it just takes forever to open. Well, we're going to go and I'm going to show you my next tip. And we are going to, there we go. Take a minute to find it. It's okay. So we're going to go to our open screen. This is the first thing I do with any part that's ever sent to me. Click the button on the screen, highlight the part you want to open. But instead of actually opening it in either Large Design Review, Lightweight, or Resolved, I'll come over here straight to this configuration tab, go to the drop down, select Advanced, then go direct to open. Now it's going to stop you, and it's going to, hey, wait a minute. You said you want to do a configured open, so you know, select a few options here. So we're going to select the third option down, which is assembly structure only. So what it's going to do is it's going to open exactly what it says, just the feature tree. It's not going to load anything else. It's just going to open the file with nothing unsuppressed. And if everything plays nice, it'll be pretty quick. There we go. Now, I've got this part. It's been sent to me. It's got a lot of ketchup and mustard on the feature tree. Well, so now I can come back through and I can unsuppress part by part as I'm going through the model and trying to figure out where those problems are. Oh, here's one. Here's an issue. And I can go through and fix them as I unsuppress those parts. It gives me the chance to fix it initially so that I'm not having to deal with this every time I open the file. But Adam's got another one to do. And so we are going to let him take over.
All right. So yeah, as we're going into this opening stuff that we're talking about, we were talking about some platform stuff, and we're going to come back to that. We're going to integrate platform with some of the SolidWorks stuff we're using. And right now we're using SolidWorks Connected. So we're staying to the most current version of SolidWorks because we are on the platform version of SolidWorks Connected. So that's a great tool. But I want to talk about another opening feature, which is LDR. Does anybody know what LDR is? What does that stand for? Go ahead. Large Designer View, exactly. And how does that benefit us? So Large Designer View is good and it can hinder us too, but I'm going to show how we can collaborate that with Fully Resolved and make a best of both worlds, okay? So I'm going to go ahead and open that same bike. I'm going to go to Large Designer View. And as I open it, it tells me, yeah, there's only certain things you can do. You can select things, you can measure things, but you really can't modify things because it isn't fully resolved, right? So I'm going to go ahead and hit OK on this. And watch how quick it opens, just like with the fully suppressed version, right? With the advanced open, it's going to open it really quick in comparison to taking the hit of a large model, right? Because if we open this fully resolved, this is a very large model, right? And that's fine. Maybe we just need that. Maybe we just need some measurements. Maybe we just need to look at some stuff. But what if there's a certain section that we need to modify, right? We've got an LDR. There's a lot of tools in the selection option menu, right? I could actually, and I've talked about this before, I could actually do a full solid hour presentation just on selection options, right? There is so much stuff in there. But right now I want to talk about, out of all these different tools, volume select, okay? Anybody know the difference between selecting something from right to left versus left to right? So right to left, or go ahead, John. Go ahead, yeah. Correct, exactly right, John. So in one direction is anything in the box, the other one is anything in the box and touching the box. So left to right is anything in the box, right to left is anything in the box and crossing the box. And the reason I bring that up is because I want you guys to keep that in mind when I'm using volume select, okay? Let's roll down here. I'm gonna go ahead and use my triad. Anybody see that triad? I was able to use that because I don't have planes to go normal to in large design review mode. And so I've already selected volume select. And if I go right to left, it is gonna select anything, you know, in the box and whatnot. Let me actually get out of that. Do it one more time. At this time, I'm gonna go left to right, and that's gonna be anything inside the box, right? So I'm gonna select, I just need to work on this upper fairing portion, right? Notice it selected anything in there. If I'd have went right to left, it would have got the stuff that crossed it. So like the tank and the forks and all that stuff would have been selected if I'd done right to left. So that is applicable in this situation, right? But if I go back into that right side view, notice I have these arrows. I can easily grab some stuff if I need to by dragging that out. That's not what I want to do though. Now look, I also have the arrows going in and out of the x-axis there. So notice I've only got, because it's inside there, I've only got the handlebar, right? I don't have the grips, I don't have the brakes, I don't have the clutch, but I want those to be included. So I'm gonna go ahead and grab the arrow and I'm gonna pull it out in this direction to incorporate that. I'm gonna pull it out in this direction to incorporate that. Now I have everything inside that volume selected. Anything inside that box, but it's got to be inside the box because right, it's left to right. Now, if I did right to left, it'd have been anything crossing it too, even in that push and pull, right? So once I've done that, I can come up to this selective open button. I can hit the drop down and go selective open, selected components only. Okay, we broke something. The open is not there. Let me restart this.
As with anything, you go to try to demo something and you break it.
Break it on the first time. There we go. Now it's not grayed out. I don't know why I grayed out all of a sudden for that one. So yeah, selected open only, and then we only want to open that selected section. What it's going to do for me is, this is talking about the whole wizard stuff. Let's not worry about the conversion. And I'll talk a little bit about that. This is really where I wanted to talk about this portion. So what it's doing is it's going to open this model up fully resolved, but only what was in the volume selected. So I'm not taking a hit on the whole model. I did a large design review, opened it up quickly and efficiently, got to the area that I wanted to work on, that I seen that I needed to work on, did a volume select there, and now I'm opening it fully resolved in just that area. Now, what's it doing with the rest of it? Well, it's not going to load it into memory, okay? And we'll see that here in just a minute. It's not going to be a memory, it's going to be hidden, okay? But it's also going to create a display state for that as well. So let's go ahead and hit okay. And notice we only have this area now. This is what has been fully resolved. I can modify, do anything, work on anything just like normal here. If I go into my configuration manager, I do have that new display state because of that, okay? And if I want to load something, it's fine. It's just not in memory, it's hidden. So all I have to do is select it, poke the eyeball, and now it's available and has been loaded into memory. And so that's another process, another way you can open something efficiently, quickly, and then resolve and work on only what you want to and not take the hit on the full model. Brad's got some pretty cool stuff with sorting mates once he got his configurations figured out.
Yeah. So here, We wait for this thing to load. There we go. So this model here was sent to me by our supplier. Anybody seen that? You open a model up from your supplier, it's all blown up. Well, seems to me there's a lot of ketchup and mustard in here. We can't, I mean, if we go down line by line like before, we could find those one at a time. But what to say if you already opened it all the way, you've opened it fully resolved, you forgot your advanced opens. Well, we can scroll down to our mates in here. And we can group the mates by status, which allows us to find, come on now, there we go. So I can just hide the ones that are already solved. I don't need to worry about those. I'm going to focus now on these 4 red mates. So we're going to come in here and try to figure out what is wrong with it. You know, it's got a right plane, and the tire itself seems to be double mated. So I guess I don't need that one. So we'll go in, we'll clean this thing up, we'll delete it out. And as it's going through with the grouped mates, it goes just to solved and overdefined here. And now we can go back through, we can find some more. Well, it looks like this one can't be added either. Can't be solved. So let's go ahead and delete that one out. And as we're updating, all of our mates are being solved themselves. It allows us to kind of go through step by step and query the model until we can get what is usable for us. So, but I don't know if you've noticed, this feature tree is kind of hard to read. Doesn't look like it's in English, does it? Well, our supplier is not from the United States or not a native English speaker. So Adam's going to kind of show how he dealt with that.
As Brad said, the supplier we got this bottle from didn't speak English. He used, I'm pretty sure it's French in a lot of this instance here. And so if we come in, let's say we just pick this tire. We did some modifications to this tire. We added some different things here. But unless you're an old school user, you kind of notice the symbols and you see those symbols and you know what they mean. But for somebody that's new, they may not, right? So I know I'm gonna butcher this in translation, but repetition circular, right? Sounds almost like Medea, circular. Anyway, so those are some different words that we may not be accustomed to or using. Right. So how do we understand that if we get that supplier model from somebody else? Well, there's an option that we can get within our system options, and I can go straight to it, right? I can go down to our feature manager selection in here in system options and select it and go to it, but I don't want to do that. I want to show you another tip and trick on the way, right? The search option, right? A lot of people don't even realize it's there. It's almost like the command search. It's there and you can use it. It's a very powerful tool if you know it's there and you do use it. Because half the time, who in here loads SolidWorks, they get it, get the new version of SolidWorks, and they forgot a setting that they set on last year's model because it was a year ago. Or if you're guilty, as some of us probably are, we may be jumping 2 or 3 years when we upgrade, right? And so you forget those settings. Well, if you can just remember a buzzword, a name, and just one word, then you can usually get there. So I'm going to start, and I'm just going to say translated. And there it is. It's the first one that popped up. So I click that and it goes ahead and directs me to it and highlights what I'm looking for, right? So I go to feature manager, select show translated feature names in the feature manager tree. And so I'm going to select that, hit the drop down, and I can select any language I want or I choose. And so I'm going to select English, hit OK. And notice what it does on the right hand in the feature manager tree to the right side of the native language. It puts it in parentheses or brackets, exactly what it was. So that repetition circular is now saying circular pattern, right? Or revolve instead of revolution. All right, just another tip and trick along the way. I think Brad's got a de-feature tool he's going to show us next.
Yeah. So now we got this model open. As you saw, it was really, really complicated. Lots of parts, lots of features. And I don't want to have to spend time dealing with this thing, rebuilding every feature. So I just opened up a sample here of the defeature properties we're going to run. How would you go about defeaturing this normally? Think back prior to when the defeature tool was created. How would you go back and make this thing simpler, or a dummy model to make this work faster for you? Because we all know more faces, more facets to show, and graphics triangles to display, it takes longer to load. So how would, this is where we get audience participation. How would you make this simpler to use?
Over here, Brad.
Yes, that's a good one. I like that. Suppress features.
Repeat that, please.
The answer was a new configuration, a simplified configuration with things suppressed. Yes, that's a good one. Anybody else? Saving it as a step file. Yeah, that's a good one. I saw Dan in the back. Image quality way down. Yes, you could do that. What about something as simple as just filling in the holes? I don't need to see the inside of this, right? You can come in here and fill in a lot of that as you go. Or removing the text. Does anybody make placards in this room? Stickers? Inside of SolidWorks? Do you extrude the text? If you do, stop it.
That's something we're having to do with our company right now. Everybody's extruding
Yes.
text for placards, and so we're telling them, that's fine if you need to do it for engraving and stuff, right? But at the same time, make a simplified version, suppress it, take an image of it and put it right back on top.
As a decal. This, because it slows your stuff down. But we'll continue on. So I'm going to need to defeature this part. Well, I'm going to use my handy dandy S key over here, find what we need to do, type in just start typing, it'll come up. The defeature tool. Oh, well, I broke it. Oops. It did.
It did get rid of all the features. Good job.
Presentation done. Awesome.
You want me to jump ahead while you're reopening?
Yes, because that wasn't supposed to happen.
That nobody has it ever crash on them, right? Especially right in the middle, you needing something done quick, right? So I'm gonna go ahead and jump ahead real quick, and me and Brad will just swap this time, and he'll pick up where he left off when he gets SolidWorks up. But I wanted to talk about this engine guard that I worked on, and maybe pick your guys' brain on how you would normally design a piece of pipe that was bent like that, right? Well, what would be the tool you use? Before we jump into that, I'm gonna have to open this. So I'm gonna go in here and I'm gonna hit, let me do something real quick. I'm supposed to have this off beforehand.
I'm sorry. Oh, well.
So
Technical
that's part of the
difficulties.
tip of trick I'm gonna actually show you with this. And so I'm gonna click the engine guard, right? And what's up in that top left-hand corner? Breadcrumbs. Breadcrumbs are great. They're very useful. We're glad that SolidWorks add them. I use them all the time, right? How do we get them to our mouse? The D key, yeah. So D key brings them to our mouse and we can utilize them. Less mouse miles equals more efficiency, right? And so when we go into that, we can select that assembly and utilize that. But there's one more extra step we can go to, is that if we go into our system options, and again, I'm using the search bar, right? We don't want to have to go hunt and peck for stuff and type in breadcrumbs. It'll take us to the display display settings, and where this is normally turned on, right? Show breadcrumbs on selections, right? That is typically out of the box. That's the way it goes. There's an option right below that that says show breadcrumbs at mouse pointer, right? And if you select this and turn it on, because default it's off out of the box, you select that and turn it on. Now, no longer do you even have to use the D key. It brings it, supposed to. Did I not hit okay? I didn't select it. Yeah, you're right.
Eric Beatty in the chat just said Bernard is shaking his head from all the bad mispronunciations of the French.
I bet he is for sure. I told you I was going to butcher it when I said it, right? So yes, now that when we select it, now the breadcrumbs come to our mouse and we no longer even have to use the D key, right? We've even reduced one more step, one more click. So I'm gonna go ahead and select that assembly and open it. And so this rod here, or this guard, when it's opened, how would you normally design a piece of rod or a piece of pipe? A sweep, yeah, most people would use a sweep, and there's nothing wrong with that. It's been used for decades. We used it at our company for decades until we realized there might be a better method, right? And because it is only a couple sketches, right? So if you come in and look at the sweep, what is it? So we look at the sweep, just very simple. Everybody knows this, it's basics, it may be a little bit rudimentary, is that you draw the profile sketch and then you have the path of the sketch that
Yes.
it follows, right? And you select that and it extrudes it along that process. And that's great, but you know, if you're just drawing this, you're sending it to an outside vendor or somebody like that, and you don't have to deal with it any more than that, maybe that's okay, maybe it's efficient for you, right? But I would implore you to maybe look at doing it as a piece of sheet metal. And why is that?
Blasphemy.
Because blasphemy, because as a piece of sheet metal, you don't have to calculate the bends. You don't have to calculate the flat of it, right? Or when you're sending it to your shop guy, right? When you send it to him, he gets a little bit more information. I'll get into that information in just a second. But first, how did I do this? Well, it's very simple. When you would draw the path, you would do the same thing for the sheet metal, right? Draw the path, dimension it out, however you need it to be, right? Click OK, and when you click OK, it comes into your sheet metal menu, and you could either set all that bend radiuses and stuff yourself and your thickness yourself. I personally say you should be using a gauge table, right? Gauge tables are not only going to help you, but if you have other people in your company, it's going to help them, because everybody's going to be on the same page and using the same stuff. Once you prove out your K factors and all that stuff that you have to do with the machine, you can put it in there and everybody's on the same page. There's no fat fingering. There's nobody calling from the shop saying, you got this jacked up, I need you to go back and fix it. And guess what? When you go back and fix a sheet metal part and you're off, what's it do? It grows or it shrinks and it no longer fits in the space you designed it for, right? So gauge tables all the way. And then once you have that designed, I'm going to roll this back a little bit. Use them, right key, roll back. Everybody knows that's there, right? Roll that back, and then I'll drop it down one. Let me unsuppress this. And this is how you would do it with fillets, right? And you go to the inside and do it as well. But if filleting it on the outside, that's one process of making it round and looking like a piece of pipe. And sometimes that's good. I like it sometimes. Now, it's not good practice to always mate things to your edges and stuff like that, especially your fillets. But if you have to, if it's a have-to situation, it does give you a place to grab and a handle to pull and rotate and maybe attach to if it's a have-to situation, right? I always say things shouldn't be done, but if design intent and have-to situations arise, maybe we need to break the rules every now and again, right? I'm gonna go ahead and suppress that down. Once you've done that, use your sweep. Cut out the outside, make it look like a piece of pipe or a rod, right? And then when you come in and you create a drawing,
Is it going to crash too?
I hope not. It usually does go a little faster than this.
There we go.
When we create that drawing, we can pull in our flat pattern, pull out our side view, set our side view to default. Now we have those views that we need. We don't have to calculate for our flat of our pipe or our rod. It's already calculated. We have bend lines to denote where you're going to put it on the pipe bender, right? So we can help the people downstream, and we're helping ourselves not having to deal with calculations too of bend deductions. Right.
Thinking outside the box.
Thinking outside the box, using tools. And I talked about this last night in my presentation of some of my peripherals I use. Taking things that you use for other things and using them in a different way can really give you that extra mile. And back to Brad, I think he's got his
Yep,
system.
we got it back up and running now, so we're good to go. All right, so we switched from the air filter because that one keeps blowing up my D feature. So we're gonna go the other route. So we talked about creating a simplified configuration and just getting rid of the features that we need. As you can see, we're gonna just completely ignore that logo over there. We're just gonna move it off to the screen because that's the shameful error of Harley. We're not gonna talk about that. At one point, Harley was owned by the bowling company, AMF. Scary, but it was. To save the company. But anyway,
Yeah, it was.
so we'll go back. We'll roll this thing down. Now, in that model that we're building, right, we're working on a fairing, we're working on some engine guards, we're working on some you know, oil plates and things for, you know, mounting up parts. Do I need to see every hole and every feature inside this carb? Is it something that's really useful in the model? We found that this one was causing some problems. So doing things like removing holes just by filling them in, cutting off features that don't need to be there, like the logo. I don't need the logo. Again, extruded text. What did Eric say in the chat? You have a water bottle around, and every time somebody extrudes text, you spray them and say, no, just don't. I like that. We just keep filling it in until we are left with, you know, the basic overall shape. I don't need to see every piece of this part. So we're going to pull up the comparison here of our D feature and our regular. And I will got to say, this laptop has done fantastic with opening these massive assemblies. So we're going to disregard. Eric Beatty also said in the chat that that's a meatball, and then the yellow triangle is a Dorito. So instead of a ketchup and mustard, we have meatballs and Doritos. You can tell who gets hungry when they start designing. So I've got these two engines here. As you can see, engines and transmissions, they look very similar. But for our purposes, we don't need to see every little bit of the linkage. We don't see this kind of K&N. You don't need to see the filter media or the hole inside or anything like that. So we're going to go back and I went through and de-featured as much as I could. So to do a little bit of A and B comparison here, let's drag this out here. And just by de-featuring, adding some holes or subtracting some holes by filling them in or using the de-feature command, we went from a half second open time to 0.012 of a second. We cut our graphics triangles down over 75%, and our rebuild time, we knocked a full second off of it, as well as knocking down the faces 2/3 as well. So all this to get to the point where we need to model some stuff, right? We need to model parts. Well, part of my task was to design a guard. I don't need to do that. Leave it alone. I needed to design an oil cooler guard. Come on now, I don't need that either. And so we're going to go in, we're going to create some patterns and cuts and things, you know, just to make a oil cooler guard. If you ride a motorcycle, you know how hot sometimes the engines get. Well, Harley's an air-cooled motor, and it uses just oil that runs through it to cool it down. So anything you can do to save your engine, this is the way to do it. So we're going to come in here and we're going to create a fan cutout for the fan. So I'm going to come in here and we're going to edit the sketch, just kind of show you a little example of how we can change a linear pattern a little bit and work with it and get the results we want a little bit faster. So you can see I got some center lines or construction lines. I got some dimensions in here, but if you notice, I threw a curved slot in, dimensioned only from the center of the slot to the center of the circle where the fan's going to mount, and just the width of the slot. Well, I've got these things mated tangent to these. We're going to call them guide curves. And we're going to pattern it. Inside, if you model your sketch correctly, you'll see this varied sketch option. A lot of the times it's grayed out because the sketch is completely defined and locked in shape. Well, if you got this varied sketch option open, you'll be able to pattern that option or pattern that cut over and over again, and it will follow those guide curves for you. Now, if I cut that off, it just models the same cut over and over again. We don't need it that way, so we'll cut that back on. Along with that, let's go ahead and pattern it around. Now we have 2 features to do it rather than having to do an extrude cut and then 1, 2, 3, 4, and then pattern it all around. We're trying to do all this in one single sketch. You know, a series of patterns can solve your problem as well. Well, we were asked to put in some oil cooler lines in and out and switch to our temp sensor to model it. Some holes, but the customer come back and says, we need to add some grating on the top so the air can get out, because you know, you've got air going in, it's got to come somewhere. Well, we need to create a no-go zone in this area that we can pattern around. We don't want the grating to kind of go in these hole clearance areas. So we're gonna take and we're gonna create a surface. Surfaces, as we know, do not have mass. They do not really have a thickness, even though they kind of show a little bit as a thickness. They're just, you know, modified planes essentially. So in the sketch, I use a singular fit spline. Now, for this option to work, you need a one singular item. So you can't do lines and fillets and stuff. This varied sketch option will not work in this situation. You got to have it as a fit spline or one solid straight line. So we come in, we'll just kind of rotate it around so you can kind of see this again. And we're going to create our slot. We'll go back into the sketch here, show how the slot was created. We have our straight line across the bottom. We don't want to get any closer because we don't want this slot to warp when we're bending in on our press brake. And then we want it to be tangent to this surface here because we want to make sure it fills up as much of this area for airflow as possible. And then, you know, I've got the radius, which sets the width of the slot, and then dimension that holds it in. So I'm fully defined. And we're going to come back in and we're going to create our pattern. Again, we have this varied sketch option that's actually usable. So if we don't, you notice that all that stuff crashes together. Then we've suddenly got really thin pieces of metal here. We got sharp edges and things we don't want to deal with. Well, because we have this keep out zone and we have that slot filling it, click the varied sketch on, and it will follow and change the shape of that slot to meet the needs of the cutout. Along with that, you know, I asked the customer, so do you really care how big those slots are or how close they are together? He said, as much as you can get in there. Well, we can come in here and we can, our pattern option that it would be the most benefit would be up to reference. And then I know that this 1/4 inch dimension is as close as I want to get to make it match, make it as symmetrical as possible. Well, we got this spacing option here. So we're going to put in our spacing. We're just going to keep getting it tighter and tighter until we can get as much in there that will physically allow us to do. But notice all of that stuff is fitting and modifying and changing as we need to. Oh no, the customer comes back and says, I don't like that. Well, now we've got our pattern. It's all linked together. We can come in here and we can change all of these dimensions. Come back up to 3.5 on this one. Let's say that switch kind of is bigger than what we thought. We got something from the supplier that was measured incorrectly. We need to make some more space for it. Go back in and parametrically it updates. It follows the surface. Well, I'm done with it now. The customer's happy. He really doesn't want me to do any more work with it. Take the sketch, hide it, and because it has no mass, no thickness or anything, there's no more need to show it, and you can leave it in there so that the next designer can come in and see what it is. Another pro tip, notice I've got my features named. Does everybody name their features? Please do it. It helps people, other people that are modifying it, or me if I opened something from 5 years ago and trying to go through and, you know, decipher what I did. Or I open one from 5 years ago and I go, who's the dum-dum that made this? And then realize it was me. So go back through, name your features. You don't have to name them all, just all the major critical ones that could affect your design intent. Because, you know, the whole wizard does a pretty good job of naming them themselves. So, all right. And Adam's got patterning stuff too, and we don't want to overlap. So let's go over to him.
Awesome. Thank you, Brad. So I wanted to talk a little bit about patterning of this foot peg that's on the engine guard. So I'm coming back to the engine guard, talk about it a little bit, but I also wanted to talk about how I developed this engine guard. How did I create it? Who here uses top-down modeling? Okay, quite a few. Who does bottom-up modeling? Quite a few. Who does both? Okay, so I figured I as well. It's basically whatever works best at the moment in time we're doing it, right? And so I did this foot peg actually in the top level assembly all the way back to the motorcycle. And that's how I designed the peg and where I wanted it. I basically created a new part in place, brought a plane off where I wanted to set it, and then kind of extruded stuff out. But how did I do that? So I want to go in and just edit the part in place, and then let's expand it out and look at the first sketch. So the way I did this is by using convert entities. One of my favorite tools ever is convert entities. Basically, I selected the pipe like I would right here, just in this area, right? And as I did that, I convert entities and it takes that whole perimeter and converts it. After that point, I go in, I think it's a 1/4 inch. Yeah, I did an offset at a 1/4 inch. When you're in offset, you can decide whether you want the base geometry to become construction geometry or the geometry going to be construction geometry, whichever one. In this case, I used base geometry. Offset at a 1/4 inch, left my base geometry as a construction geometry, and then allowed that to solve out for my piece of sheet metal. Then I went in and added flanges to it. When I added the flanges, I also came back in basically the same way, added this cut extrude in the flange, brought the flange halfway through the pipe, added a cut extrude with that circular edge there as well as down here. And then I did an offset of that, left the base geometry again, construction, and offset it enough to where when it would leave enough room and tolerance for me to set that there and be able to weld that foot peg to it. Right. So I just wanted to talk about that, give maybe some tips and tricks to people who don't understand what convert entities or whatnot is. But then when I go in and I open this guy, I added a forming tool feature. I went ahead and created that forming tool feature for that. So I have these little gnarled pieces all through it. So when your feet's up there vibrating on the hog, right, you got a place to hold your feet and grip the soles of your boots, right? So I put that forming tool in there, and then I went and patterned it and did a linear pattern down. And then I did this curved pattern, which is a little interesting. I think some of the bases is set to like this, and that's definitely what I didn't want. So I said I would rather have it in the offset curve to kind of follow that and then be tangent to the curve on all instances. So it kind of followed everything the way I wanted it. And I basically used that linear pattern and that forming tool pattern forming tool feature to create that. And that's fine and dandy and that's good. But what does my performance evaluation say? I'm about 1.25 seconds, almost 1.33 seconds, right, in my performance evaluation. That's not horrible, right? Not bad. But think about this, and I use this, and I use my next example on smaller scale bases, so I don't have to sit here and wait an hour to show you the example. Because when this is on a larger scale, a bigger part, more patterns, more of these in my top level assembly that I'm passing downstream to maybe somebody else, this can really slow down my productivity at opening and rebuilding my models, right? How do we fix that? What can we do to fix that? Well, there's a simple little solution that I'm going to talk about right now that'll actually help you. So remember that we have 1 1/3 second. Our curve pattern is 72% of the rebuild, right? That's the biggest hitter. That's the one that's hitting us the hardest. And then if we look at our linear pattern, it's up almost 5%. So it's up towards the top too. Let's close that. Let's look at the linear pattern by itself. Anybody ever look at geometry pattern? Anybody know what that is? Okay,
I
so
I see some couple head nods in
see
here.
some head nods. That's good. So if you just do a regular pattern, it's basically saying I need this feature here, 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 and here. Right? Basically everywhere I did that linear pattern, it's recreating that feature. to do geometry pattern, it's almost like it's taking a screenshot or a snap picture of whatever it is on those faces and stuff, and then kind of just moving those into place, right? And so that's where it's really making our win. So I'm gonna go ahead and check this. And sometimes I wish that was a sticky setting or a setting that could automatically be done automatically by SolidWorks. If you're hearing me, listening, yeah. keep that.
Enhancement request.
Enhancement request. Leave that on or a sticky setting, one or the other. I know sometimes you can't solve geometry, and I understand that. There are some patterns you just cannot do geometry pattern with. It will not solve it, right? And maybe that's why they don't do it. But at least give me a note if that's the case. Tell me, okay, I got to turn this off. Because more often than not, you can leave that on and it works. So we're just doing the linear pattern at this point. We're gonna come back and look at the performance evaluation, and we have dropped almost half of the time in rebuild just by that one pattern. Now our curved pattern went from being 72% of the rebuild time to being 56.5% of the rebuild time. Our linear pattern it's down. Yeah, it went way down to like 2%. It's dropped almost to the bottom, right? So think how much that's made. And we just did it to linear pattern. Let's close that. Let's go to the curved pattern here. Let's turn geometry pattern on for that one too, right? Hit okay. Look at performance evaluation. It's a third of a second. We have really dropped that much. We've dropped probably 75%, if not more, in efficiency. We've gained that much, right? We've dropped that much more latency, I guess you would say. And where's our curve pattern? Man, it's not even at the top. It's not even our heavy hitter anymore. It's moved down to what, about fifth at 13%? It went from being 72% originally down to 13%. So it's not even causing us issues, and our linear pattern, of course, stayed the same because we really didn't change much. Just a cool little checkbox so we can check to make our job and our life a little bit easier when it comes to patterns, especially when we're looking at them on a large assembly, a large setup.
Well, you know, he was requesting the speaker box. We got to get that done.
The speaker box, we do got to get that done here in just a minute. I did want to real quick bring up for discussion in the audience and see if you guys want to give some feedback on this. Who likes feature patterns versus sketch patterns or vice versa?
About that, yeah.
Yeah. Feature patterns. What'd you say? Feature patterns? Feature patterns? Feature patterns? That's good. I'm glad everybody's kind of unanimously saying feature patterns, because
Yes.
sketch patterns are good, but I'm going to talk a little bit about those sketch patterns and feature patterns and just what is the difference? What are we looking at when we're talking about that? So this is the engine guard plate down at the lower portion of the motorcycle that I've got. Now I did this just as another basic example that I wanted to show for a couple instances here. Let me go ahead and suppress the feature pattern and unsuppress the sketch pattern. So in my tenure, things I've done, I have noticed that sketch patterns, in my opinion, aren't always reliable, right? You can create a sketch pattern, and more often than not, you have to go in and add more dimensional or relationships to it to fully define that sketch pattern. Sometimes you can get it to add one, but you inevitably usually have to go and add another. Right. Then if I decide to come in and modify something on the seed pattern, now look, I can go ahead and prove this is a sketch pattern. We can see it over here in our existing relations. But then if I come into our seed of our pattern and I modify that in some way, what happens to the rest of those sketch patterns? Do they update accordingly? Not really. Not if I'm changing the main profile of it, right? So they're good and they're okay, but then I'm also, look, imagine a new hire coming in and opening this, not really knowing SolidWorks very well. What is that? Where do I start? Right? That's a lot of sketches. That's a lot of lines and a lot of information for somebody to sit there and look at, even if you aren't a new hire. You know, imagine it being something completely different and in more detail.
Yeah.
Right? This is pretty simple. So I'm going to go back and suppress that one. Actually, before I suppress that, let's look at this. Let's go to performance evaluation. 3/4 of a second on performance evaluation. And our heavy hitter is that sketch pattern. Okay. Okay, so now let's suppress that one. And then let's unsuppress the feature pattern. And before we get into talking about some of the stuff we just talked about with the sketch pattern, let's just go ahead and right off the bat look performance pattern. A third of what the sketch pattern is. 1/3. I've seen this be up to at least 10 times in difference between a sketch pattern and a feature pattern. That feature patterns are that much more not only robust, but efficient, right? And then we go back and we talk about that new hire, and he comes in and he opens that sketch. What do you think he thinks about that one?
A lot better.
I can deal with that, right? I
Yeah,
can look
a
at
lot
that and
better.
change, yeah. And then if I change that profile, what happens to my feature pattern? Everything updates accordingly. And I also like to preference that with make sure you're not mating to your patterns or your feature patterns. Let's mate to the seeds or something different, because anytime you change something in your seed and the patterns out there, regardless of sketch pattern or feature pattern, you're going to break mates and you're going to cause a lot of Doritos and meatballs.
You're making me hungry now.
I know, we just had food.
I know.
So let's see. So yeah, that's good. Also with the sketch patterns, Brad mentioned with his pattern, he did that up to surface kind of thing. You can't do that with a sketch pattern. You can do it with a feature pattern, though. So rebuild times are a little bit longer with sketch patterns. It keeps your sketches nice and tidy by using feature patterns, so you don't have to worry about that as well. And then we talked about the performance hit. And so, yeah, I'm a proponent of feature patterns. Now, I caveat that with a lot of things I say and do, right? And I said this earlier, design intent speaks everything. I don't want to tell everybody just to go and use feature patterns only, right? Because there may be an instance or a time where you need a sketch pattern or a mirror, right? And that's okay. It's not to say it's wrong. If that works for you and it's more efficient, then maybe do it. But don't do it all the time. You know, there are more efficient avenues to be had.
And, you know, part of our job at Altec is trying to figure out the most efficient way to build models and help out the newer users, so that going through our modeling standards group, our centers of expertise, this is the fastest way we've come up with keeping parts modeled. But, you know, we've done all this extra stuff that he didn't ask for. He wanted the fairing.
The fairing, the speaker box. Yeah, you wanted to have that put on there, right?
Yeah.
And we talked about that sketch in the beginning, and I decided when I did that sketch, done surfacing, right? I've got my expert, so I've taken the surface professional advanced surfacing exam and got my surfacing exam. But when I looked at that, I said, I really don't want to go back to surfacing. I'm not a pro at surfacing. I passed it. Took me twice, but I passed it, right? So I'm not a pro at surfacing. That's not my daily gig. And I want to go ahead and thank Dan again and Matt Clegg and Suchit for giving us some tools to use, the platform tools. I had seen X-Shape before. I've been to World and I've seen people demonstrate it and illustrate it. And so I've seen those things. And I said, well, it behooves me, if I've got the tool, why not try it, right? So for the first time ever, I went into X-Shape and I decided to try and make this fairing, the speaker box. And when I did that, I decided to record it. Now, granted, I sped it up and it did only take 5 minutes per this video. It took me about an hour and a half, 2 hours in real time. And that's my first time ever touching X-Shape, right? So I want to go ahead and play that video for you. And I'm going to kind of talk about some of the stuff as it goes through there and what all it is. So I come into the platform. Of course, I go to X-Shape. I design a new component and name it. I click the cube, locate it on there, make the sizing accordingly, how I kind of want it. Then I decided to go ahead and make it symmetrical. So about that plane, so that way it grows and does everything between the two different planes. And I'm grabbing nodes, I'm grabbing edges, I'm grabbing surfaces and pushing and pulling those to make it the way I want. I'll go ahead and grab the top and pull it up a little bit, grab that edge as well. I'm going to flip it around to the front here in just a second, just to pull the bottom in so it's not as tall. I grab the top and I twist it around. I want to try and break that wind. I don't want just a parachute on the front of the thing, right? So I'm breaking that around a little bit. And then I do the same thing from the side, break it around, give it some little bit of aerodynamics to it. Then go to the inside. And there's a little bit of a pinch in there. So I'm going to pull that out. Grab that surface and pull it out. Grab the edge and just fine tune it and finesse it a little bit to where I, Graphically, it looks okay.
Mhm.
Now I'm gonna go in, I'm gonna extrude the surface a little bit and mess around with that speaker box. Go ahead and increase that speaker area and resize it. And I'm not gonna lie to you, the speaker part area kind of threw me for a loop, and it was just because of the 3D space, trying to orient it and understand it. And in the process, I realized that the triad that I'm using to move things around, when I click it, is kind of reference based off that surface and off that edge, right? But then you'll notice I look at it, I'm like, oh, okay, that is kind of sucked in, and I twist it out. And when I get over to the other side, I right click and happen to find that I don't have to do it from that reference. I can actually right click and do it from the X, Y, and Z, right? And be relative to that. And that's what that was right there. I think it was right there. It's coming up. But I can set it right there. That's the X, Y, Z. Then I change it back to being, referenced by that surface or edge. And that helps me out kind of fine tuning things, pulling it around, pushing it around a little bit. And we're just about done with that speaker area. Fine tuning it, finessing it, making sure everything looks good. Then I get a measurement and realize, the size and stuff of it. And as I do, I go to scale it. Now, the first time I didn't grab the object to scale it. That's why I errored out. And you see the little ketchup over there, meatball. And so I see that's good. Okay. Then I come back, I delete that first one out where I actually did it on the second one to get it to the right size. Now I'm going to save it and I'm going to export it out as a step file, right? Why am I doing that? Well, we have SolidWorks connected, right? So I'm going to open it up in SolidWorks connected. And just my operation, I don't know if you have to do this, but I decided to go ahead and save it from a step file to a part file. That way it was native more to SolidWorks. And then once I do that, I go over to the bike and I pull it in. I go ahead and made it to the center plane there. That way it's lined up in that orientation, go to the side view, you give it a little tweak and location where I want it. And then I realize after this that what's in the way? The headlight. Remember that little arch I drew in the sketch? Okay, that's cool. Well, I'll go ahead and do that here. I'll go ahead and measure it out, see where it's located, come back into that part file that I've created, put my sketch in location in there and cut it out after it's fully defined. Make sure everything's right, fits up good. So then I come back, put a fillet in, drive the fillet up a little bit to cut out the sharp edges. And I'm gonna go throw a feature on here. This feature, anybody know what the hotkey is for copying a surface or an appearance? I'm sorry. Control-Shift-C copies the appearance. Anybody want to take a guess of what pastes it? Control-Shift-V, exactly, good job. So I basically copy it out and then I'm going through here, I'm clicking all these different surfaces that I want and I do a Control-Shift-V, paste it on there. I go into modify that appearance a little bit and map it a little bit better. Realize I need it at the bottom, so I'm gonna go ahead and just add it there with a Control-Shift-V. I go back to the bike, Control-Shift-C, the paint, come to the inside. Now this I want to show real quick. Let me pause it right here. So you see where it says select connected faces? On the front, I just clicked them all. I was trying to illustrate two different ways of doing this. I clicked all the ones on the front, but on the back, I went to a centralized location and then I right click and I say select connected faces. And because of that, I only have to select 4 faces on the back and it selects basically everything I needed. Then I paste that paint, Control-Shift-V, grab some black for the speaker box area and the underneath side. Come back into the bike and there it was. So you've seen the contrast of me first time ever using X shape, that even a newbie can create something halfway decent and throw it into his motorcycle in an upfitting type job and utilize that. So then I take it and I pass it off to my good old buddy Brad here and say, Brad, I know you downloaded that Visualize Connected. Do you mind throwing that visualization in there? And we found out something different between when we looked at the package, between the model versus the paint color of the package.
So it turns out the model we got was an initial run through, and we were also supplied an actual visualized file, and we noticed that it's not red anymore. So I had to kind of figure out what to do. And, I've got this fairing in here, and with the options allowed inside the Visualize Connected, it's just like the one that's on native software. We can come in here and modify everything we need. So I don't like the way this is at, so we're gonna come here and move a dimension a little bit, rock it back a little bit more. Doesn't look too good. We're gonna keep rocking this thing back a little bit until we get a dimension that looks good to me. And you can come in here and translate and rotate and get things exactly how you want. And, you know, with this visualize, I want to be able to show, like, I got this picture of the background and it just so happens to be in the parking lot where this is going to get delivered. So I'm like, we'll get this thing, we're going to set it up, and we want to make sure that we render this correctly. So I threw some flames on there. The ones that Adam used, while looking good on the model, we had to obviously go get a new one inside. So, you know, I created this thing, Paul's bike. We're going to render this thing out. And, you know, using actual nice processing, which was awesome for this machine. We're gonna watch how fast this thing renders. Now, if you notice up here, Visualize Connected is actually working offline. You have the option with these connected softwares to disconnect from the 3D connection portal and work offline. So if you know you're going to go on a plane, you know you're going to go on, let's say if you're like me and take your computer with you on a cruise ship or something where there's no internet, you can do some work if you have to. But notice, got it all rendered. We can go send it back and, you know, check it off the list. Because we're done. Actually, we need to finalize all this stuff here. So let's get this over with. We got to drink some beers later.
Drink some drinks.
Yeah.
All right. So before we go and check it off the list and what Brad's talking about, we're going to talk about that just in 1 second. But I want to congratulate Brad, because not only did he put that note in there and I went in and put that sketch in there, he decided to come back to the whiteboard and throw those images of the rendering in there in the whiteboard as well. So just to keep it and close the loop. And it also made the note that this is the renderings from Tank. So we knew. I also wanted to mention something else about the whiteboard that we did. And we messaged each other in the messaging part of it, right? But we could also message each other within the whiteboard as well to keep notes there. Now, when we go to check it off, we found this really cool project planner in a platform, right? With Inovia, that we could go in and keep track of what we were doing in our tasks. And so if we just look at the summary tab, and you can message in here and create comments in here too, so that's really cool. But just to talk about the summary tab, we talk about our milestones. The one project we have currently, we have 3 in our to-do tasks, 6 that we need that are in work, and then 2 that are currently completed. There's none at risk, or sorry, 5 at risk. Or sorry, 5 not at risk, 1 at risk, and 3 that are late, according to our timeline in which we set for this project. You can see the burn down between the different tasks and how they're paying off and coming through the process and based on the dates and stuff. You can see the resources and what's being used. 1 person here, 2 people here. You can also come down and even check and make sure the work's divvied out accordingly. So you can see that Brad's got 4 and I've got 4 tasks each as well. Now, when you want to look at those tasks individually, you go to the task pane, and as it loads, you'll see what is specifically in the to-do list, what is in the work list. If we come up here and set this to all, you can see what is being completed. So we got the bike pack, right? That was completed. Brad got the oil cover done. That was completed. But we also have a few things in here that are dependents upon others, right? If we look at, say, the fairing bracket to mount the fairing, it has a dependency upon the fairing being done. Of course, you can't make a fairing bracket without a fairing. And I think the rendering is the same way. So the rendering that he just did is the same way. It's got a dependency of the fairing being done. You can't render a fairing without a fairing, right? So of course it's got to have a dependency. So you can create that. And when you create a task in here, it's pretty simple. I mean, it's like, if we want to create a new task, let's hit the plus button and let's call it
Delivery.
Yeah. Send or mail bike, whatever. Let me get my caps right. Send the bike. And as soon as I hit enter, it created the task here. I could open that task. I can change the title. I can add a description. The parent is the project you're working on. You could link it to multiple parents if you wanted to. You can set the priority, right? So is it a low priority, medium priority, high priority, or urgent priority? You can change the maturity state here as well as at the task itself if you don't want to come into it. Give a percentage of it being done or not or completed. Then your planned and end start date. Now it's going to automatically do the start date based off the date you create it, and then usually always gives it a 1 day estimated duration. You can change that. It's currently set to fixed, but if you toggle that, you can change those dates and change your estimated duration. Add attachments. That's another cool feature. If we go to, I'll come back to that one in just a second. So yeah, you add the dependencies, bookmark files, whatever you want. You can also assign it. So, you know, I'm gonna be out of town. My son's getting married here in a couple of weeks, so I'm not gonna be able to send this bike and deliver it, right? So I'm gonna say, Brad, that's your job.
As long as I get to ride it.
As long as you get to ride it, there you go. And then you can make comments on it as well. So I'm gonna go ahead and close this and look at the defeaturing of the large parts, and you can make comments based on the tasks, right? And so this task was for Brad. He was talking about the defeaturing stuff. I'm like, Brad, we really need to get this model to speed up. Let's do some defeaturing. And Brad says he's working on it. So you have that communication tied to the tasks within the project planner, right? So that's another really cool feature. If we come down to the new renderings, we notice that when Brad created the renderings, we were able to upload the attached files, and we can go in and preview those and look at them as well. And it'll populate that. We can send that and share that with other people out in the world. We wanted to send that to the customer and let them see it. All right, we'll close that. We talked about dependencies, and there are dependencies, and you create those in here if you want. You can also look at them up here. You can look at the schedule a little bit more in detail if you want to look at it in this view to kind of see how things are progressing, where they're at, what's late, that kind of stuff, right? You can see the dependency here of the speaker box where the fairing brackets are tied to it, and so are the renderings, right? And then if you go and look at the dependencies themselves, you can see that information here as well and investigate it, click on it and look into it. The members that are involved in the project that you've assigned stuff to and link to the project. And then the content, this is anything and everything that you may have attached to one of those tasks that you had. For example, this was part of a fender thing that we were looking at with patterns, and the customer didn't decide he liked it. So we're saying, okay, well, we just won't use it then, right? Then you come back out and you come back to your main stuff.
I think that's about it, right?
I think it is. Let's jump back over for our outro here. Wrong one. Come back to me, mouse. So just some notes for taking away. If we were in the audience, what will we have written down?
Whiteboard's good for brainstorming and showing off ideas.
Try different open options other than fully resolved. There's other things out there and ways to open stuff without taking huge hits.
To use your patterns efficiently, explore the options as you go.
Explore the 3D experience platform. There's some pretty cool tools on there that you can hone in skills and collaborate with your SolidWorks. Again, I want to take this time to thank Dan Wagner, Matt Clegg, and Suchit and all those involved in helping the Champions program and the user group leaders get those tools in their hands to really flesh out this stuff and work on it and be able to do presentations like we just did today.
And most importantly, have fun, just like we've had today. Don't let the daily grind of work and the stress get to you.
Call to action. We love to call to action. Give it a try. Just one thing. Everything you've seen here today, you're not going to take every bit of it home with you today. I mean, you will, but will you remember it? Will you be able to utilize it all? But I guarantee at least one nugget you can take with you and use. Where will you start? I always say practice does not make perfect, it makes habit. And Aristotle said, we are what we repeatedly do. Excellence then is not an act, but is a habit.
Questions? No, I think we're good.
Right here.
converting to mesh bodies. I haven't had a chance to play around with that much. Just with my normal workflow doesn't have that opportunity. So that'd be something to try.
It was something with point cloud and stuff. I know that can consume a lot of data,
Well, no, just converting to a mesh bot, a solid
like
body.
a STL or something. I think somebody else may have mentioned that too. Gotcha. Yeah, it's definitely something to research. I know with our team at Altec, we have a handful to handful of people, individuals that get together as a modeling standards, modeling COE, and that's what we do. We tend to try and break stuff, right? Once a year, we get together before we roll SolidWorks out to everybody. We try and break it so we know what that may need patched or what we may need to send out to people with warnings. And I would suggest maybe doing that with your company. We do RCIs, rapid continuous improvement, right? Where we get together for a week at a time and we just go through and break stuff.
Yep.
Yeah.
Cool.
Any other questions right here? We use envelopes a lot. It's not gonna change your surface triangles. I actually have an envelope presentation I do. I've done it last year at World, and if you need a presentation of that at another SWUG group, I can do it. We do use envelopes. We use it more for workflow process than we do anything else, because really it's not gonna add any mass to your model, right? That's the biggest thing. It doesn't add mass and it doesn't add to your bill of materials. That's the big win for it. And so what we do is we say we have several prints and we're flowing something down an assembly line. We say, okay, this is your job. This is what you have. Here's your bill of materials, right? And then we throw that envelope into something else and say, okay, the next guy, this is your job. This is your stuff. Here's your bill of materials, but this is what you're building it on, right? And that's kind of the process in which we use the envelope. And I think that's a really unique process, or a best case. I also talk about my envelope, how you can take vendor parts and bring them in, or customer supplied parts and bring them in, and using those envelopes to understand how to mount or work with that specific model.
Okay.
And not cause mass or things on your bill of materials or anything.
All right.
Any other questions, right?
Adam, I'm gonna cut you off a little bit because Jason is menacingly squeezing his stress ball at me. I think we're a little over time. I do want you guys to have a little bit of a break. So get with these guys with your questions.
Guys, as we're wrapping up too, we taking a little break here. Everybody can get up and stretch your legs, hit the bathroom. A lot of the stuff you showed, the platform, right? We know Suchit mentioned this at the beginning here. In July, all new licenses of SolidWorks, if you buy a new license after July, comes with access to the platform directly from the native desktop SolidWorks, right? It's an add-in that runs inside of SolidWorks. So a lot of the stuff these guys are showing here, we're going to have floodgates opening here in July. So again, want to make sure that that's clear. If you have any questions about what that means, even your existing licenses, what it means for those, let us know. We can chat about all of that with you while we're here today, but just want to make sure that's clear too. Cool.
Configure, design, and sell custom products in record time with DriveWorks CPQ for manufacturing. Create your own configure, price, quote solution powered by DriveWorks rules-based automation. Automate the creation of all the data you need to sell, design, and manufacture custom products, from simple parts to complex systems. Save time throughout your organization, reduce errors and time-consuming rework, sell more and respond quickly. Rules-based guided selling enables sales teams, distributors, and customers to configure custom quotes and visualize selections in interactive 3D on any device. As changes are made and options selected, the price updates in real time. Use your company-specific rules and data to control currencies, discounts, and more. Sales data and quotes are generated automatically. In your customizable workflow, notifications can be sent, approvals requested, and further downstream documents created. You might also decide to automatically send the quote directly to the customer, so they have all the information they need to place the order straight away. In the background, DriveWorks automatically creates the order-specific manufacturing data needed, including 3D parts, assemblies, drawings, bills of material, and much more. Integration between DriveWorks and other company systems ensures that the data can be linked to your ERP and CRM systems. As part of your workflow, the data can also go through a final review before being sent to the shop floor. Throughout the entire process, DriveWorks keeps everyone up to date with alerts, notifications, email, reports, and more. Deliver configured products in record time and exceed customer expectations.
Okay. How's everyone doing? I'm Jason Pohl. I work at Dassault Systems at the 3D Experience Adoption Team. Work with Justin, Elise, Andy, Todd Trout, and they make me look great. I work with an awesome team, really smart people, okay? Something I'm not used to doing. And it's just been a great experience. So the reason I'm here today, I guess the why I'm here today is because, you know, Dan Wagner asked me to come and present here at IronSWUG with Brad and Adam. And the biggest reason why I'm here today is because, you know, my entire career as an industrial designer, I was an absolute super fan of SolidWorks, okay? It's one of the tools that I was able to learn and use to create my job possible, to bring my dreams to reality. So in the back of my mind, I always thought that the people that work at SolidWorks must be like these like incredible geniuses that are like superhuman. Okay. So it was like in my mind, it was like, you know, one day I'm going to be able to work at SolidWorks for Dassault Systems. So it's just really cool to be here. And it's just been a crazy ride. So that's why I'm here. Okay. And I'm just going to tell you a little bit about my unique workflow as an industrial designer and what gets me out of bed in the morning and what inspires me to continue to create. Okay. So that's me. I'm Jason. All right. And there we go. Next slide now. Next slide now. Click. All right. So one more try. I'm going to hit the button one more time. Nope. Okay. The clicker is on. It's okay. I'm going to do this instead. It's going to be great. Prepare. Nope, that didn't work either. Okay.
Okay, we broke it.
The world leading technology. And bring Jason to the party. Bad things happen. Okay. It's a great slide too. Telling you. Just hit the button, Tank. It's good. Now, it's a lesson in overcoming adversity, you know? Yeah. Right now I got a picture of you, Tank. It's a good looking picture. I like it. I might use that as my Facebook profile picture for me. There we go. That's me. Yeah. Okay. So how about that weather, huh? Pretty nice outside. How about we go outside? Oh, okay, great. So here we go. This is the slide I promised you. Okay. So, you know what? This is like circa, you know, I was born, all right, and you know that was introduced to me, okay, and along my life I've had you know, my sisters, my family, my teachers, they introduce new things to me. You know, it was Play-Doh. You know, I was like, oh, this is cool. You know, I can make stuff. Then it was crayons, markers, you know, and it just went on. And, you know, then I, you know, took a drafting class or something and a shop class. And I was like, I'm welding stuff together and I'm like, metal, neat metal, you know. And I always had these people, you know, show me these new tools along the way. And just when I was, 16, 17 years into it, I thought I knew everything. I just need SolidWorks, nothing else. Stay away. I know what I'm doing. I was introduced by Justin on my team to X-Shape. Okay. And X-Shape is really like transcended who I am as a designer and what I can sculpt and what I can create in 3D space. It just compounded who I am. So, I've had a lot of help along the way. And I remember being in high school, senior in high school, and I was always painting and sculpting with clay and just having fun, because that's ultimately what I do every day is I just strive to have fun with what I do and enjoy life, no matter what it is. Okay. So I remember that I had this art teacher, Mrs. Connor, and she told me to, do what you want. There's so many different jobs out there. You can create this, you could create bridges, you could make signs, you could do artwork. That art is everywhere in everything that we do. So, I took that and I was like, wow, this is cool. What do I want to do? And I decided I'm going to make video games, The only problem was I was in the middle of a farm in Illinois and there wasn't a lot of people making video games. So I went to art school and I got a job right away making a PlayStation 2 game, some Xbox games as an animator, 3D modeler. And what I loved about it was you were able to just create and build things and you were able to make the decisions and create. So that's really what got me started in the direction I'm on. And then, I did the video game thing for like 6 months and I was like, okay, I want to make something like real. I want to make something tangible that I can hold and use. So ironically enough, I got a call from my good friend, Pohl Sr. at Orange County Choppers. And that's what got me into the industrial design, sphere of things. So let's see, this is going to work maybe. So yeah, so it's kind of working. No, it's not working. Oh boy. So yeah, this is a really cool sizzle reel that I put together from my days at Choppers. It was just really cool to be able to have the experience there. If you don't know what Orange County Choppers is, we were a motorcycle shop for a really long time on Discovery Channel Network. And I spent 16 years there as the lead designer. And there you can see me throwing a bike that happened to slip out of my hands. And there I got a chance to go on the Time Bandit in the Bering Sea and really travel the world. We built a bike for the tourism board of Malaysia, tourism board of Australia. So with 164 countries every Monday night and a camera in your face and a producer and, you're 22 years old and you're learning SolidWorks. So it was like really a challenge because you never really wanted to screw anything up because you felt like the whole world was watching, so there was some tense moments, but I had a really good time. And here's just a few of my favorite bikes coming through, and they're not playing really smooth right now. I think you can tell that, but it plays really good at my computer back in my shop, jams. So is it? Okay. Yeah, so it's a stream thing, but yeah. And you know what? I had a lot of opportunities to work with a lot of different brands, Fortune 500 companies, celebrities, and everyone wanted these big choppers. And I had a chance in 2005 to design the SolidWorks chopper, which is here and it's in the cafeteria. But I was told they took the gas out of it. So, and the real reason I'm here today is because they said GP was gonna jump his bike on a ramp. So I came to see this, but there was confetti. The confetti was cool, but I thought there would be a ramp. So fake news there. Yeah. So yeah, this is me in my workshop at home. I live upstate New York. Get to do a lot of cool, fun projects. A lot of them I'm capturing my process and sharing with all the different communities. And Dr. Dashboard, I got more content coming for you on all those swim communities. And yeah, I have a lot of fun. One of the projects I do, I've made them for years, is the WWE championship belts. If you've ever turned the television on, you see the big wrestlers hold up the belts. That's made in my shop, all the TV ones. So that's fun. It's a fun project for me. And just like doing that kind of work, So I have a CNC machine, a 3D laser, and good stuff like that, that keep me busy. Jason doesn't sit still well. I really like to have like one machine running and another machine running, and then like doing like a crazy 3D model with like rendering something at the same time. So I usually have multiple things going on. But yeah, this is my process. I was asked by my manager, Justin Burton, to come up with my process to share with everyone, because I think it's important that other industrial designers just maybe see how I do things, to not do them or, learn from them. So yeah, my thing, it's circular, how my brain works, and everything's always evolving and coming around. So the first phase is the understand phase. This is where you're like, why am I doing this? Is this for me? Is this because my boss told me to do it? Is it, what's driving me? Because what drives you is what's going to make that product better. If you're currently not making something that you believe in and have passion for, there's really no sense of doing it, because life's too short. You might as well move on and make something else. So what are the rules here? And this is where you really need to like slow things down and listen to what maybe your client's asking, what your manager wants, what you want, and you need to understand what you're doing. Okay, so that's phase one. And sometimes that takes 5 minutes, sometimes it takes 5 years, it depends how well you're able to listen to others and to get that goal. The second phase is the concept phase. This is where you become really brave. You dance like no one's watching, you're just crazy lunatic, and you throw out all the rules that they set in front of you and all the guidelines and this material and that, throw everything out and you just draw, you sketch. That's what I do. I've always been sketching. I'm the guy in the back of the class just sketching. What'd you say? So sketch everything down, create an art board. This is where you borrow concepts from other people. Okay, you borrow nice pictures of the latest Lamborghini, the interior of the new Porsche, and you see what other people are creating, and you make an art board of things that trigger your mind to be better at what you're making. Okay, and that's okay. Maybe it's just a texture that you saw and you're like, wow, I could really use that texture in this design that I'm working on. So the next thing is the design phase, the third phase. And this is where, you break into the 3D modeling. And I love it. I'm a 3D modeler. That's what I set out to be when I was a kid. And that's what I still pride myself on doing. But that's where you start modeling things and you see different shapes that you didn't see before when it was on paper, because the shape just starts to evolve, So that's where I get in there. I change colors, do some renders, things like that, throw in Visualize, see what makes the design better. Okay. And then the fourth phase for me is prototype. I'm a machinist. I spent a lot of time in a motorcycle shop surrounded by a lot of CNC machines and water jets and this, that. And I make everything, sometimes it's on a 3D printer, sometimes it's on a 3D laser, sometimes it's on a CNC mill. I like to get my hands dirty. Coolant runs through my blood, it's mostly coolant at this point. And that's where, again, you listen and you get feedback from your peers. You use the product yourself. That's the biggest thing, is if you're designing a product you don't really use, sometimes it's harder to really make it better, so if you can use it, go for it. But that's my design phases, 1 through 4. This is my son, my oldest son, Maxton, and he had a riot working on me with a project. I decided to take X shape and create a fishing lure. I did this last summer, so it was a lot of fun to be able to take a concept and, I jumped into X shape, modeled it real quick in X shape, and then I was able to go into SolidWorks and split it into 3 different bodies. I like modeling the parts as one part. I'm that crazy guy that, I've always avoided assemblies just because I'm like, I just want to work on one part, but I broke this down and I did a hinge-like mechanism in the center. And then I located it with dowel pins, epoxied it together, bondoed it, and then I airbrushed it because I like airbrushing too. It's just another toy, and so I airbrushed it and took it to the lake next to my house and caught a bass with it. It was fun. It was exhilarating, I made this and I'm fishing with it. I was that crazy guy in the lake celebrating when no one was looking, and Yeah, funny story. I was making a video and I had my camera like set up in the rocks, and I'm like got my little tiny boat, and I'm like, yeah, you know, like fishing, and it kept falling over, and my neighbor walked by, and I'm like, hey, can you get a shot of me fishing? And he's like, sure, Jay. So anyways, I don't know why I felt the need to tell you that, but I did. So here's a project I got to work on. I don't know, probably 10 years ago or better, and it was for the FBI. Okay, and this motorcycle was really cool. Like the gas tank like split over, and it had like the issued Glock and the badge, and the other ones slid over and had the handcuffs. It was like gimmicky. You know, we did these like shocker bikes that were like really over the top. And one thing I remember modeling is the badge on the back. That was pretty intense at the moment, you know, and that got all 3D machined, and it was crazy. And the wheels really stood out to me as like an obstacle. Like, okay, I want to do this. No one asked me to do it. I was the designer. I got to pick how difficult it was going to be. And so I set out to make these eagle wheels. Okay. And I did this by using SolidWorks. And at the time it was the freeform tool that I used. This is gone. And I did a bunch. You can't really see this because the video is not playing, but all the way down my stack here. Let's see. Oh, maybe I'll just hit. I got to hit play. Sorry, guys. Okay. So, yeah, you can see the detail in this. I mean, I have the eyebrows, I have the beak, I have the nostrils of the bird, and I put some design to it. And how I modeled this was I modeled it like with a bunch of lofts and cross sections, and it was really intense. And you can see my stack, you know, all the way down. It just keeps going sketch after sketch. I used something called the freeform tool, which was great, but it was kind of hard to control. So I really needed a better way to model organic things than inside SolidWorks, you know? But I got it done. The wheels looked great. They got gold plated, I think. Or were they chromed? I don't know. No, they were not gold plated. The badge was gold plated. Anyways, made this wheel in SolidWorks, but it took like 2 weeks. Okay. It took like way too long. And I think my clicker needs batteries. Okay. Got one over here. Oh, it went. Oh, there we go. Okay. So now I start things out a little bit differently. Now I go in this beautiful thing called X shape, and I start everything with a box. I love it. It's symmetric. It's simple. It's easy. And with a box, I feel like I can make anything that's complex. Okay. And it reminds me of being that kid again and starting with the mush of Play-Doh in my hand and just being like, what am I going to make next? So like here's a few of the things that I made within the first year of using X shape. You know, I did a shark for fun and a rodeo dude swinging around a guitar on a bull. And I remodeled that in 15 minutes, did a monster truck with my kids, and then the SWUG Me car. Okay. That was a lot of fun with the SWUG Me team. I want to say hi to Eric and Heather and Joe and Todd, who are watching us live right now. What's up, guys? And did Wolfie. That was one of the first things I ever modeled. Then the fishing lure. So you can see all the different things that I'm able to design and build and create just with a simple box. And the best thing about it is it happens really fast. You know, it's not slow. So these guys, okay, Brad and Adam, Bradham is what we like to call them. I think they're crazy. You know, I don't sit well. I don't sit still well. Jason doesn't like to sit in his seat, you know, like I'm that guy, bounce around a lot, I like to have a lot of things to do. And one thing I just can't do is just drive, you know, and I get bored, I fall asleep. It's dangerous, you know? So I thought, okay, well, what if I did go on a ride with these guys? What would I have to do? What would my bike be, you know? But first I'd probably have to get permission from my wife. Okay. And she would probably say no. She'd probably be like, no, Jay, you're not going with those yahoos. Okay. And she's like, what, you know, because I have four awesome kids. So she would say, well, you know what, if you go, we go type thing. So did some research on a thing called the internet. And I found this. So I thought this would be perfect for my family to go on a long trip with Bradham. Okay, you know, you got the look, like there's like a range you could cook. You know, I could make some. I'm big into cooking. You know, I do some chicken Alfredo back there, maybe some chicken parm. But you know, I figured, you know, me and the kids could hang out in the back, and my wife could drive, like on most family trips, which is what happens. And I could play Minecraft with my kids in the back, and she could get us to wherever we're going. You know, but I like the idea. It's got a boat on top and everything. So thought that was great. And then I was like, okay, so let's say I did have to do something in SolidWorks. You know, I wanted to make a bike again, flashback. It's, you know, 2004, I'm making motorcycles, right? So what do I need? You know, well, need a V-twin motor, okay, number one. So slap that in there. And I need a large fuel cell, okay, because we're going to go 2,300 miles. So I don't want to stop for gas once, because then I'm just going to buy junk food. I'm eating beef jerky. I'm like, what am I doing? I can't eat this, you know? And saddlebags, because if I'm going to do this, Brad and Adam got to pay me so much cash that I need something to carry the cash around in. I don't know what y'all put in those saddlebags on these are the luggage racks on the bikes. I don't know what goes in it, but mine will be cash. Okay. And, you know, rain gear. Yeah, rain gear. We'll get to that. I've experienced that. A toolkit, because, you know, things always happen. So I'll need a toolkit. What else? Snacks, definitely. Windshield. Been on a ride in the middle of a rainstorm, thunder and lightning wind. In the rain, it was like this big cold rain, and it felt like nails hitting my face. And I was like, this is not cool. I'm on a 10-foot chopper, you know? Like, what am I doing? So I need a windshield. A cow catcher, that's a thing on the front that kind of clears off stuff. I'd need one of those. And they used to make them on trains. It's what's on the front of a train. Look it up. It's designed and engineered in SolidWorks, probably. So running boards, because I don't sit very long. I get cramps in my hips. So I need to stand up every once in a while I'm going down the road. So I'll need running boards. Road rage system, we won't get there, but you know, something that releases like marbles, or you know, people text messaging driving on the road. Like I just wouldn't end well, guys. That's why I'm not with you riding. It wouldn't be good. It's like, Jay's in jail. What'd he do? Well, something about a quick release mechanism system. I don't know. So yeah, and here's another video, and I'm sorry that we're experiencing some lag, but this is like kind of what I was thinking that I would go with. Now, this is a reverse trike. It's got two wheels up front, and it's also a video that's not playing. So I'm just gonna walk back here. And Tank, I remember you said you'd hit play for me. Yeah, no, it's cool. It's good. I got like a system here. Step over this. So yeah, I did this with Andy Barnes, calls them insert ordered geometrical sets. It's a great name. Love saying it. Can't say it enough. But I did a whole bunch of them, and it's just a fancy way of saying like a new part, new component, you know. So this was very quick. I did this in probably, not counting the motor I dropped in, thanks to Michael Steve sent me that motor actually. But yeah, I did this in like an hour and a half, 2 hours, just having fun. I didn't have a sketch or anything. I was just like, yeah, this is great. And then I got done with it, and I'm like, I hate this bike. I just hate it. So it just had like a plastic feel to it, you know. But there was one area I really liked, and in the back, like I tried to extrude everything so it kind of came together. So yeah, right there. I like that shot, you know, right, something right in there. Let me hit this button. So this is how I used to do gas tanks in SolidWorks. And a lot of times I would make these elaborate gas tanks. We'd send them out to LA, and this place would make these huge bucks and stamp it out. Later on at at life at Choppers, we got our own Beckwood press. It's 350 ton. We could pop out these gas tanks. But I got nervous every time we made them, because when you're doing it and you're dealing with the sheet metal, it could tear, it could bend at a different point, wrinkle it. And whenever there was changes, my hands would start sweating. Like, yeah, you know what? We're gonna have to change that gas tank just a little bit. And I'd be like, oh God, please no. So, because I remember, all my different cross sections and everything I would have to go through to change it. And yeah, I could update it pretty quick, but sometimes I couldn't, and sometimes it'd blow up, and I'd just be, why is Jason crying at his desk again? So now, let's see here. So I did another sketch, just real quick. And this was like, I went out to shut the lights off in my office. And then next thing I know, I'm sitting down and I'm like sketching a motorcycle. And I'm like, why am I doing this? What did Brad and Adam and Dan Wagner's to blame for this, and I sketched this motorcycle. So I'm like, okay, this is great. I'm going to make a gas tank. I'm going to make just this gas tank right here. So, oh boy. Okay. Let's see if I can hit the play button one more time. Okay. So this is like my workflow inside X-Shape. And it's similar to what you just saw in the last presentation, but I like to get my bearings. I like to see where that chair is in 3D space. And then I bring in my sketch and drop it right on the plane. And then I click the advanced button and go to like this thing called on-screen points. It's just a way to scale everything. So I take this point, put it there, put that point there. I know that's about 19, 20 inches. Boom, Bob's your uncle, send it. And that scales up the picture. So I know I'm working in the ballpark. I know there's a lot of engineers like, well, that doesn't work. And you're right. But to get a concept started for an artificial bike for a thing called IronSWUG for Brad and Adam, this works. Okay. So yeah, I start with a box. Like I said before, a box could be anything. So I just popped that in there. And I was asked by a lot of people to slow my mouse speed down. Because, before when I'd model something, it would just be for me. And I just, I'm modeling it and I'm making it. And sometimes the mouse goes up, goes down, all around. And now I'm trying to do things so other people can see it. This is called the robot. Okay. So anything you do on this, you could grab the dots, the arrows, you can move, you could translate it. So once you master the robot, which takes like 4 minutes of just like, you know how to use X-Shape. So it's made so that anyone can pick it up and start modeling with it right away. And that's what I love about it. So yeah, I'm just going to go to screen mode. I like screen mode because I control the orientation. As a modeler, I'm always rotating and looking at it. Like if I was, sometimes I'm like, find myself like bobbing and weaving, looking at it like it's in real life. But I just like to be able to adjust it. So a simple scale, non-uniform in that direction. And I'm off to the races. And I make this gas tank pretty quick, but what used to be a bunch of sketches and intersections is now live, like speed modeling right in front of me, so something like this, I call it a sock model. Okay. And I think it might be a term that I just like made up one day, but I just sock it in, and it's really loose. So it's like a concept model, but it's amazing because it's watertight and I can make anything with it. This could be any product, it doesn't have to be a fuel cell for a V-twin motorcycle. So yeah, this is just kind of the process of me going about it, and just hide the sketch so I can just kind of see everything right here and run with it. And I'm not sure what I'm going to do next. Right now I'm thinking, and I think I'm going to straighten this out a little bit. Yeah. So again, I'm just scaling. You can just double click on the edge and it selects that whole loop all the way around, which is brilliant. So yeah, I'm going to rotate that in a little bit. And yeah, this is X shape. This is how I use it. And next I'm going to be, saving it to the platform and then opening it up in SolidWorks and making a finished part with it. Okay. Yeah, so I think I do an extrusion here pretty soon. Yeah, I think I'm fixing to do that. But you see how the shape is just like it's able to be manipulated so easy. There's no lag in the computer. It's instant, and that's the magic of X shape. And it's a browser based software, so I could be anywhere. I don't have to be on my supercomputer at home. I could I could be on my wife's laptop or anything. So there was a quick extrude. I like the idea of having, a gas tank that you can get your knees tight to, like a knee relief plate type thing. So doing that, threw a crease on it. And yeah, I'm off to the races. I'm modeling a gas tank here in minutes. This wasn't sped up at all. It was actually slowed down because I had to slow my mouse speed down, which I don't ever recommend going slower, So yeah. And I think I do an extrusion on the top of this, but I'm going to speed this part up because I think it needs to be sped up a little bit. There's a nice little extrusion there. Oh boy. Okay. I don't know how to speed it up. Tank. There's Tank's gonna come help speed this up, right? I don't know. I can't because
All that's yeah.
got all this jazz there.
All the shareable stuff.
Yeah, it wasn't counting on that being there. Yeah, we'll just bump this. We'll save everyone 5 minutes. Like that. Right. Yeah. Okay. So yeah, this is I just bring the sketch back in. I'm just tightening up this model a little bit. I got a really organic shape, something that I'm starting to like for this bike. And I have the sketch back on so I can really see like what the other parts are going to be and what I need to do. It's great adding different color to designs right away. And, with the software, you can do that instantly. Sometimes, light reflects different ways with different colors, and you're able to see different things that you as a designer see value in. So yeah, I'm just doing a quick save, and I'm saving this to the platform. I name it Gas Tank 01, so I know how to find it later. Smart. Oh my goodness, what is this? Oh my goodness, I'm excited. Whenever I see SolidWorks, I get excited still. This is like home to me. So I go into SolidWorks, I go up here, and I'm going to type in Gas Tank 01. There it is. I started a new part, by the way, and I just drag and drop this. Okay, this is that X-shape file on the platform in SolidWorks. I go to inch pound because I don't even know what MM stands for. No idea. So yeah, so I switched that. And then, you know what? This is just the different. I like to see my planes a certain way here. I'm weird like that. So I actually put the front plane going down the middle of my part, which is close to being like something an insane person would do. I'm either really passionate or really insane. But yeah. So here we go. I got my part in SolidWorks. I've oriented it. And now I'm just going to dump a shell on it because I got to know, is this thing watertight? Is it going to work? So I just do a simple shell, and I'm like, it can't be this easy. It can't be this great, but it is. There it is. So the shell works. So now I know I'm cooking with the right kind of peanut oil here. Okay. I'm excited about it. I think my next step is just to drag up so the shell is below. And yeah, I'm just going to drop in a backbone. So this is the exact same practice I would have done years ago when I was making bikes. So just the easiest thing for me to pull this off. And I know it would probably be a real radius and things like that. I just slapped an arc, any old arc, and I'm gonna do a sweep cut, you know, like what? You know, yeah, I do a sweep cut and a couple of fillets and then I'm out, man. That's it. So let's see the sweep cut go through. Yeah, I just drew like, you know, the profile and the path. So the path was sketched first and just going to extrude this through. And I just save it right back to the platform. And then this is the unedited version. So this is me modeling the front fairing in real time without, you know, slowing my mouse speed down. And I just do a quick extrusion there. And, you know, it's a lot of the same commands that I'm doing. It's not a whole list to pick from. It's, you know, it's really basic stuff like it's push and pull, it's rotate, it's scale, it's crease and edge to make it sharp, you know, non-uniform scale to grow it in a certain direction. And it's just, it's a lot of fun, you know. Yes. So I guess I use X shape because I find myself having the most fun when I'm using it. So have a great time doing that for sure. And then okay. I think I need Tank to come back here next, maybe. Yeah. Nope. Okay. Yeah, I think, was that it? I don't remember. Yeah. So that's what I have for you guys. Yeah, it was just that's my workflow. That's how my crazy brain works on the different stuff I do. And this is, you know, where you can reach out to me. I'm on Instagram a lot less these days, and even Twitter. And that's my email address right there. LinkedIn, YouTube. I always got great stuff that I'm trying to generate for all the communities and on YouTube as well. So yeah, that's me, right? Yeah. Thanks. Good. Yeah. I don't got any answers. Told you everything I know right there.
Much.
Yeah.
See you.
Yeah.